Hello everyone, my name is Gunwant Patil. I am from FY MTech Instrumentation Department from College of Engineering Pune, and my today's topic is control valve. So starting with the basics of valve, let's see what is valve. Valve is a device used to regulate the flow of fluid flowing through it by opening or closing or partially closing the passage of flow. For understanding, suppose there is a pipe and a valve installed on it, and if the valve is closed, the fluid flow doesn't passes through that, and if the valve is open, the fluid passes. The motion of this stem that opens or closes the valve depends on the two motions, that is linear motion and rotary motion. So there are some types of valves depending upon their motions, like linear motion or rotary motion. Here are some types of gate valve. Gate valve having the stem that moves linearly, hence the linear motion of the stem. Globe valve also having the linear motion of the stem. Butterfly valve is rotary type of motion. So these valves is to be controlled remotely, hence the term control valve is introduced. So control valve. Control valve is a valve with pneumatic, hydraulic or electric actuator that automatically, fully or partially opens or closes the valve to a position according to the signal received from the controlling instruments. The main parts of the control valve are valve body, positioner and the actuator. Here you can see the valve, control valve completely. The actuator works on three types of signals, either pneumatics, electronics or hydraulics. Pneumatic actuator. Pneumatic actuator adjusts the position of the valve by converting air pressure into rotary motion or linear motion of the stem. Here you can see in the image, the air pressure is given to the diaphragm from the upside. Hence, when the pressure increases, the diaphragm bends toward downwards and the plug closes the valve. This type of valve is called as air to close. And in the reverse action, when the air pressure to the diaphragm is given from the below, which will open the valve, it's called as air to open. The piston and diaphragm actuators are examples of pneumatic actuators. Then hydraulic actuators. Hydraulic actuators consist of a cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion gives an output in terms of linear, rotary or oscillatory motion. Electric actuator. An electric actuator is powered by a motor that converts electrical energy to mechanical torque, and hence the stem moves upward and downward to open or close the valve. Then comes the next main part of the control valve, that is positioner. Positioners are the instruments that help improve control by accurately positioning a control valve actuator in response to a control signal. Positioners receive an input signal either pneumatically or electronically and provide output power to an actuator. Suppose an I2P converter is given and the output of that I2P converter according to the current received. The current is converted into the pressure, and that air pressure is given to the actuator that we have seen in the previous slides. The actuator moves the diaphragm and hence opens or closes the valve. Hence, positioner plays a most important role in the control valve. There are some valve characteristics. The characteristics of valve is based on the flow output according to the change in lift of plug. Hence, if the plug is open, the flow, how the flow visualize, like there are some characteristics of valve like equal percentage, linear, quick opening. From graph you can see for a small percent of opening of the plug, the valve in equal percentage characteristics opens equally in linear characteristics. Here are the types of plug depending upon the shapes and the characteristics they possess. So first you can see a quick opening plug. Second is a linear plug. Third is the equal percentage. Quick opening. The quick opening plugs quickly opens and the quick opening characteristics. Quick open plugs are used for on-off application designed to produce maximum flow. Linear characteristics produces equal changes in flow per unit of value of stroke regardless of plug position, and these are used where valve pressure drop is major portion of the total system pressure drop. The third characteristic is equal percentage. Change in flow per unit of valve stroke is directly proportional to the flow occurring just before the change is made, generally used for pressure control. Thank you for wishing. Thank you. Thank you for watching this video.